welcome back to lecture video on introduction to tensor analysis. In this video, we want to draw the line between covariant and contravariant and covariant vectors. So please try to be attentive so that you understand this as you understood or as you have learned the introduction of the tensor. Now, don't forget that I used the word vectors there. From our last class, we discussed types of tensors. I told you that tensors can be categorized into what? Into two rather. So the first one, you can categorize tensor in terms of rank. I'm saying that you can categorize tensor in terms of variance. Now, this time around now, vector is an example of what? It's an example of tensor. Vector is one rank tensor, and as a matter of fact, there I can interchange. I can write contravariant and covariant tensor, or contravariant and covariant vector. So whichever one, we are still saying the same thing. Okay. Now, don't forget, tensors are, like I told you, generalized mathematical objects. They are objects that extend. They are just an extension of scalars, vectors, matrices, and the like. So these are the basic things we discussed in the first video. So in this next video now, let's look at how to differentiate between contravariant and covariant vectors. Now, if n quantities, let's say A1, the index are up there, AN, in a coordinate system. This is a system. This coordinate system is written this way. Okay, beautiful. And are related. Let's say these quantities in this system are related to another n quantity, n other quantity. That means they have the same dimension, n other quantities. But this quantity is A bar 1, A bar 2, so A bar n. Okay. In another, so that coordinate system will look like this. We have this here. Another coordinate system. How do we express that coordinate system? It should just appear like this. X bar 1, okay, X bar 2, comma, X bar n. You can see these are the coordinate system for this quantity. These are the coordinate system for this quantity. Good. Now, by the transformation equation, let's look at how the transformation equation is formed. By the transformation equation. Now, without missing words, we said it in the first video that when you are transforming from one frame of reference to another, so you start with the endpoint where you are transforming to. So this time around now, our frame of reference now, the initial one now will now become the former one. I mean the final one. So the final one will now become the initial one. So we start with this second one. So the second one is where the transformation will start from. So in this case now we have what? Let's say we have A bar P. This P is a summary for the n, n quantity. So it's going to be P is going to be 1 to n. You're going to see summation. Now the partial derivative of a frame of a coordinate system here, the bar P, yes, all over. Now remember that we are moving from this coordinate system to this coordinate system. And I told you that this coordinate system now, this second one will now be the first we are going to use. That's why we are adopting A bar P. So our new coordinate system now, because we are transforming from the first to this second one. So we start with the second one. So it will be A bar. Now instead of writing 1, 2 to n now, okay, instead of writing 1 to n, Okay, we will just A bar P. So this P, later we're going to say P is what? 1 to N. Okay? Okay, that is it. Now, what do we write here now? You see, it's going to be del, that is partial derivative of del x. Now, we are picking it up here. Okay? Now, instead of writing everything there, we could write what del house q. Why? I will explain to you why it is q. A superscript q. Asking how? Why? Good. Now, this is the logic. This is the logic. Don't get it twisted. Now we are moving from this frame of reference to this frame of reference. And this frame of reference has the coordinates of the one with bars. This frame of reference has the coordinate without bars. Good. Now, if you want to move from that one to this one, we start with this new one we are moving to. So it will now be what? Partial derivative of, don't forget, let's put q will be equals to 1 to n. Okay? Now, how do we get this a q? This a superscript q now is representing this one. Yes, we are, I've written that q is equals to 1 to n. This, if this is for q, and this quantity also, it begins with 1 and stops at n. They have the same dimension. So that's why we have said our q will be 1 to n too. So we are transforming from the new one now to the old one. So that is indirectly we want to transform the old one. That's what it means. So that's why we have a bar p. I said p is defined. If you look at a bar, they have the same end quantity. So p now has represented all these the generic quantity 1 to n. So q also, which stands for this. So that's just the q we are using here is to demarcate, is to tell us that we are talking about the second frame of reference. Okay, so a bar p now will be summation of del x bar p, because our coordinate systems for a bar p is x bar 1. So del x bar p, remember p is 1 to n. This is just a conscription of everything. Now all over d s q, the hex of q, which is with respect to this. Okay, so that is it. We can write this one. If you don't want to write everything here, you can say it's the same thing as, you can say this is the same thing as del x bar p all over del s q a q. Yes. So we bear it in mind that this has represented summation convention. So that is it. Now this type of transformation is with respect to contravariant vector. How? Fine. Contravariant vector, if you remember vividly in the first video we discussed, contravariant vectors are superscripted. So you see that the index is up, super, up. The indices are up, they are up. So that's why we call it contravariant vectors. So you can now say they are called. So let's write it here. Let's write it here. Let's write it. These are called components of a contravariant vector. Contravariant vector or contravariant tensor, like I told you, contravariant tensor of the first rank, or first order. Don't worry, I will explain to you. Of first order. Now, what do we mean by first rank or first order? From what we just did now, we said a bar p is equal to summation, del x bar p all over del s q a superscript q, and I said q is moving from 1 to n, where p is also from 1 to n. You know, that's what we just did now. Fine. Now, what do we mean by rank? How many index do we have for this quantity? You know, for the frame of reference, we have only one p. This one. Q also has one. So that's why we now say these things now are components of contravariant vector. Originally, they are contravariant vector because the indices are written up. They are superscripted. And 2, because we have only one in this index for each of them. So it's called this what? Components of contravariant vector or contravariant tensor of the first rank or first order. So let's look at another one, which is talking about covariant tensor or vector. Okay, the covariant one is just the opposite of the contravariant, so it's a very simple thing. So we can, the definition will go the same way, it's just the transformation will be different. Now, if n quantities, let's say you can see that a1, a2, obviously you should have known that this is completely different. Okay, in a coordinate system, let's say the coordinate system is like this. Okay, let's assume it's like that. Are related to n other quantities. They are related to n other quantities. Okay, let's say this other quantity is this a bar 2. You can see that this is almost the same as the other one, except that the position of the variance of the rank in an order differs. Coordinate system. Okay, let's say x bar 1, x bar 2 till x bar n. By the transformation equations. Now our transformation equation this time around will be what? Yes, because why? You observe that the position of the indexes is below. That is what? Subscripted. You can see below. So the frame of reference has subscripted positions of indexes. So for that reason now, it will now be a kind of, you know, derivation now, because you know what? Del x all over del x bar 1, you know. Now, but you know, summarily we could put this so that you know you can use p to 1 to n and the like. So that's it. Yes, obviously, and a subscript q. And you are wondering how? Come, don't worry. Let's start with let me show this also. Well, we are still going to remove it. It's more or less q is equals to 1 to n, and p is equals to 1 to n. Don't worry, I will differentiate for you. So we can remove this summation index, the summation sign, by having what? The x q all over the x bar p a q. A bar p is equals to, so we have removed the summation index there. We have removed that. Now, looking at this, these are components of covariant tensor or covariant vector of the first order. The index is 1. Now, obviously, let's look at the differences. The other one, this components of contravariant vectors or contravariant tensors of the first order is like this. So you should be able to understand the differences now. That one is like this. I hope you can still remember. That one is this. Now this one is this. You can see. Try to understand the differences. This is contravariant because the index is up. This is covariant. Contravariant, covariant. Look, just look at it. The only difference is just what? Is the positioning of these indexes. And here, when this one is up, this one is down. You can see, that's all. So try to understand the differences between the two, so that in the later course or in the later aspect of this course, you will not have any issue when I explain, more, because we are going to discuss more of this in terms of higher degrees, when the quantities are not just of one dimension, when they are more, we are going to discuss more of that. So for that reason, try to understand what. So this last one now, I said they are components of what? They are components of covariant vector or tensors of rank 1. These ones are components of contravariant vectors or tensor of rank 1 or first order. So that is that or that. For now, like I'm trying to give us packages that will not be too long for us to really assimilate. So I remain Dr. OJ. In the subsequent video, we discuss more on introduction of introduction to tensor analysis. Please don't forget, click the notification bell so that each time I upload a video, you'll be daily notified. And don't forget to like and share my video links. Thank you. God bless you.